All right, now we are recording. Welcome to our second session of Fusion. Today, we are going to be reviewing and repeating a few things that we have done last week. With the addition of, we are going to focus and work on assemblies and try to put everything that we're building together. The assemblies aren't a difficult task, and that's why I'm really kind of reviewing a lot of what we went over last week. So I'll start off with just creating one assembly, because I know that is the title of today's session's assemblies. But as you see, we still have to complete the model and add more components to our model to be able to complete it. But what an assembly is taking our individual components that, if you remember last week, we made one that is the bottom, and then we made a partition. And again, if you notice, some of them may not be exactly the same name if you're just watched or are going to watch the previous version from last week. I did forget to save the model and the models that we worked on last week. So I did have to recreate it. I tried my best to recreate it as exactly as we did it, but probably didn't get it exactly. So anyway, what a model assembly is being able to take the individual components that we have created. One is the bottom, and then here we have the partition. It is basically assembling that as if we were assembling it in real life. It gives us a chance to check fit, get a orientation to see if we like how it looks when it's all put together. So we're going to look at that. We're going to look at creating a copy of components that we already have created. We're also going to look at the mirrored options to be able to mirror objects around. And then again, just basic assembly and sketches and modeling in general. So we're going to build on what we did last week. But again, first, we are going to get into what is called assembly. Now, so we learned last week about constraints within a sketch and within the heights of the model using the modifying the configuration parameters. So we will get into that in a bit. But the constraints that we have within one component to another, they call joints or being able to assemble. The first thing that we need to do in creating an assembly is ground one object or one component that we do not want that component to move around. So an example of that is we are going to end up making this component fit into this dado here. And when we move that, if we don't have one of these two objects grounded, things are going to get a little wonky on us, where the bottom might flip upside down to fit here and vice versa. So we really want to ground and start off with one object grounded. For those that are coming from SolidWorks, Inventor, and that type of software, it's just locking that position in place. So we're going to lock this bottom in place by right-clicking on the component that we have in the list. So we have the bottom component in the partition, right-clicking on the component that we want to ground or anchor into place and select ground. So that now means that when we start building our assemblies, this bottom piece is not going to move. All the other components that we have designed are going to move onto that component. So first, let's just quickly look at rotating this around. Always bouncing around from CAD to CAD, forget what buttons do what. So I'm holding the shift key down as the press the center button to be able to orbit that around. And I'm going to orbit that around to where I am able to see the edge of this partition. We want that edge to fit down into this dado right here. So we're going to first select the face of the partition. And it actually doesn't need to be selected. And hopefully, let me just show you how it is, and we're going to do it several times. So clicking the joint button is now asking us for component 1. What do we want to have? So as you hover your mouse over top of any one face, you see it kind of highlights a white kind of color. And then we also get this little circle protractor kind of thing with different points that are showing up, where we have the a white dot, a little arrow, there's a square triangle. And notice that that circle is kind of snapping to these different components. So what we are doing is selecting a point that we want to align to another surface. And I will mention, as you come around here and select it, it's sometimes difficult to not have that bounce around. So once you get the face selected that you want to have this applied to, hold the Control key down. And that means that no matter where the mouse is, it's only going to be that face. So notice I am selecting like the midpoint of the bottom of that face. So just zoom in and we can see where that is located. Now what we need to do, it's asking for what do we want to mate this to. I'm going to come over, rotate around, and select an adjacent position. So as we see, we want it to be here, and I want it to line up with that circle right there. And you can see that it's now moved itself into place. So I'm going to say OK. And we can see now that that is an assembly that we're starting to build. And with our dynamic components that we've created, well, actually it's a word from SketchUp, within the change parameters, we now have, I'll use a SketchUp term again, a dynamic components, to where we've modified and changed all of these. So if I want to modify the length of this, rather than it being 72, again, we come in and make that 60. And we see everything just kind of changes all by itself. And then one parameter that I added for this week that I didn't have last week, or at least I don't think we had, is this height parameter. The height is what I use to constrain the height of that partition. So let's make that 36. And well, it didn't change. So we're going to figure out why. It may be that I didn't constrain it yet or give that a dimension. So we're going to take a look at creating and fully constraining an object. We have, again, two components in our list. The top one is like the overall model. And I apologize. I know this is tough and there's a lot of information here. We're going to take it. We're taking it fairly quick, but we're coming back and going to do it slowly again. There's going to be a lot of repetitiveness in today's session. So the top is the entire model that has all of the parts that are going to make up our final cabinet. Then within this tree, we have our components. So we have our bottom component, and we have our partition component. Right now, we are editing the model. And I know that because it says it is active, and that is set option set right there. If we want to modify the bottom, I'm going to set that bottom as being the active component, or the partition, if we wanted to modify that partition there, we could do that. So that's what I'm going to work on, is that partition, to see why when I changed that user setting or that user parameter that it did not change. So we're going to take a look at that. And again, from last week, let's just delete that. So we could start all over with what a user parameter is. So first, before we get into that, I'm going to look at how this partition is dimensioned. So I'm going to open up the tree here so we can see all of the different sketches that we have within there. I have the sketch turned off and there's only the one sketch. So I'm going to right click and select Edit Sketch. And it flipped us to the right side for some reason. So I'm using the little box here to flip to the top. And we have just some hard-coded numbers here. Well, one hard-coded number and one number that is has a formula behind it. And that's what this FX is referring to. And if you just noticed, when you hover your mouse over top of there, it gives us that formula. So it is the length underscore y divided by 2, subtracting the material thickness and subtracting another dimension of 1.01 inches, which is the offset here. So what are those made up variables? Those made up variables are what I just deleted the 1, and we're going to change this 24 to a variable. So to do that, I'm going to finish this sketch. Don't want to edit it anymore. I'm just going to go up to Modify and change parameters. And click the plus sign to add a new one. And we're going to give it a name. And we're going to call that 26 inches. We can come back and change that anytime. I'm going to say OK. Then OK. So now coming back in to edit this sketch. I'm going to double click on the 24 to allow us to change this number. So I could change it to a 30 if I wanted to. I mean, that is just awesome that it's that easy to change the size of a rectangle. But if we want to control that much easier using that user variable that we just created, you know, right click, or I'm sorry, double click. And this time I'm going to start typing height. And we see that list of parameters showing up. So now we could change the user parameters to the height and then enter. So now we see it's 26 inches with the FX listed there. So I'm going to finish that sketch. Now notice that when I edited that sketch, it laid it flat off to the side, because that is where the sketch is actually drawn, but we've moved it to the assembly. So that sometimes gets to be a little confusing on how that plays out and works. So I'm going to go back. Yes.
Do you mind a question on that?
Not at all.
So do you recommend when you're doing bigger assemblies, sketching off to the side like that with that shelf and then putting it into place with a joint, or sketching it kind of in place?
Yeah, there's lots of opinions on that. Me, for me, I do not prefer either one of those methods. For me, I like to have all of my objects drawn independently of one another. And I'll just point out what I mean by that. I'm going to look at some other files that I have here. So these, it makes a little arcade station. And all of these components I've made independently of one another. Then I've imported them separately to create the one assembly. So that's the way I like to prefer to do it. And if I am forced to do it the way I'm doing it today, I prefer to draw them off to the side.
What's the advantage to that in your opinion?
I do not think there is an advantage. It's just what I do. Yeah, that's it. I just like to keep things separate and not build up. The main reason why I like to do them separately, as I did in that arcade, is if there are any parts that I ever plan to reuse outside of this main assembly, it makes it easier to duplicate and move them around and bring them in. Sure. There is one disadvantage of doing it the way I like to do it, and that is these user variables that we're talking about here do not apply across all components when they're drawn out separately. So that's my method there.
Gotcha. Yeah, the reason I ask is I've done some larger assemblies and without any joints, just kind of drawing things in place. And if you go to like change your material thickness or something towards the end, after you've got maybe 20, 30 parts, oh man, does it make a mess. So that's I was curious how to prevent some of that going on.
Yeah, I don't use Fusion all that often, but I use other programs similar to it. And they're kind of called, inner design inner design relation. I do not like to have those because you modify one part, the other parts may or may not stick to the constraining. So when they're at least drawn separately, I know I have physically made it and did its joints and its constraints.
Yep.
All right.
Thanks.
So, yep.
What was the formula again for the width? I know the height was 26. It seems like the other formula changed since the last time we.
It probably did.
If
like
you
I
could
said,
just bring it up, I'll take a screenshot and then I can enter it.
Yeah. Where the width.
Length. Okay.
So those parentheses are probably not needed. I put them there just to keep my brain straight on getting everything in the right order and sorting it out.
What was the length again? I might have that entered from last time, but I can't recall.
The length is yeah. Let me take a look at that. These are all the parameters here. Have length Y, what it was. I can't remember what we had it labeled earlier. I kind of tried to watch my own video and I couldn't stand listening to my own voice. I just kind of skimmed through it.
Okay, thanks. I took a screenshot, so I got it.
All right. So what we are going to do right now is, since we have one done and completed, we need 1, 2, 3 more to make. And what we could do is make a duplicate copy of our existing one and make a copy of it. There's a couple ways of doing it. We could set up a pattern, but I don't like doing patterns. I like, again, individual parts. So we're going to make a duplicate copy of this partition. So if I just right click, select copy, then coming up to the top, I'm going to right click and select paste. And it pasted it directly on top of where the other one was. And I just kind of moved up out of the way, and notice that it has a partition :1 and our partition :6. Well, that, in your case, it's going to be 2. I've been playing around and duplicating, so I'm up to 6 here. So what this has done now is made us pretty much a clone of our one component. So if we needed to make adjustments to this, say if I want to add a couple holes here for a dowel to go through to put up a shelf support, we could modify this partition 1, and I'm going to create a new sketch off of the face of partition 1. We could draw in a circle, and let's do a 3/8 circle for the dowel. And I'm going to do another one. And again, feel free to ask questions. I know this is like some of what we went over last week, but we have new folks here, maybe listening just to seeing sketches. So I've got those 2 circles drawn. I want to constrain those, and several ways of doing this. I like to use reference lines, or what do they call them here? Construction lines. I've turned the line type on to be construction. And what this means now is I'm able to snap a line And I'm purposely drawing those off of an angle just so we could see what constraints are and what they do. So we have this endpoint and this endpoint here that I always want to be to the same edge of our part, or maybe even to the center of that part, the midpoint. So I'm going to use the midpoint constraint, selecting that end dot and then selecting the line. So that just automatically snapped and positioned this line to be the midpoint of our line span. Now, if we do it on, back up a little bit and set these two lines to be horizontal. I'm doing this to set up a over-constrained situation. These two lines here, I want to be horizontal to everything. So setting the horizontal vertical constraints and just selecting all of these lines that I want to have horizontal. So the horizontal is now going to keep this circle and this circle always on the same line or the same plane. Now, if we come back to the midpoint constraint, because that's what we have, a midpoint here to this side, well, sure enough, it allowed me to do that. I was expecting an over constraint because I did not expect it to allow us to do a midpoint on both sides like that with the horizontals there, but it did. An over constraint is when you dimension a part and have one object needs to be a variable. So I'm going to set this dimension to be 2 inches. And also this one over here, I could say 2 inches, but better yet, I'm going to use the constraints to set it to be equal. I'm going to set this line to be equal to this line. So when I want to change it, I only need to change just this one variable and both come in. I mean, it's like magic. So now an over constraint would be if I try to dimension this center point here, it says I can't do it. And the reason for that is something needs to give. I'm constrained here. This line and this line always needs to be equal to one another, and it is equal to that 2 inches. So I cannot have this dimension here. Now it could be that I have it not dimensioned by the 2 inches here, but always have it dimensioned by this center to center distance like this. Now the challenge that you'll run into dimensioning the way I have it right now is, remember we've set the width of this to also be a variable. So if at any time through reduplicating or resizing, the size of this part becomes less than 14 inches, our holes are now going to be on the outside of the part. So it's not going to work out so well. So it's think about, even though, yes, this does work, it's not the best way to do that. It is better to constrain it in a way that is going to be apt to resize, or if the part gets too small or too big, at least we always know it's going to be the way it is. All right, so now we've got these holes. I'm going to finish this sketch and I'm going to use the extrude, which is a way of cutting that hole. I'm going to select both of those. If I hover around so we can see what is happening here. We're getting this to be able to pull. Oh, look at that. It's like magic. You know, it's a clone, right? The other side goes at the same time. So we're going to set the depth to a negative direction because we're cutting into it, and we want it to be equal to our material thickness. So since it is a negative direction, we're going to have to do a little bit of multiplication by -1 to be able to make that material thickness a negative number. And I'm going to say okay to this extrude. So that is what this :1 is doing. So if we have a clone or a duplicate part from one another. If you modify one, it's going to make the other a duplicate and always keep them the same. So if we always want all of these partitions to be exactly the same, making a clone copy would be the method that I would use. And again, as we're doing this, we could start building in and throwing in our parts to make our assembly at the same time. So I'm going to uncheck the visibility of the sketch where the body of the part is still visible, but the sketch is no longer visible. And coming up into the table assembly, setting that option there, and gonna run and make another joint, the partition here to here. And the other thing to think about with the constraining is how parts are shifted around. So we've constrained this part or these two holes to be a universal part that could be flipped in all directions. So right now, if this part was sitting just as it is, we know those holes are going to line up. But when we go to assemble this, and what is the top and the bottom of this part? Well, in our case, it does not matter. So we'll see how that works out. So I'm going to assemble by using the joint command. And I want this part. Again, you can see how it kind of bounces around there. So wherever that circle is, we need to select the corresponding location of the part that we want to mate it to, which is right down there. And well, see what happened there? It didn't work as magical as it did the first time. And that's okay. We have this set right here to, let's rotate that to 0. And it flips itself around. And once that is there, it will say okay. So I just wanted to show how that it's being flipped around and still being able to keep those mirrored, and it's kind of a mirrored image of it is what we did right there. So now using our change parameters, did I ever come in and change that height? So let's see. I'm going to take that to 36, and it did. And we can see that we are now 36 inches tall on those, and those two holes moved up the same and equal to one another. Back in and just change that to a 24, and they move back down. So now it might be the case where you want a duplicate of the part, but that part is going to be slightly different than any of the other components. So it might be that we need one more partition where we need to have the holes and also some sort of other cutout in it. But we don't want that cutout to be all of them. So we don't have to start completely from scratch. We could still make a copy of the component, but we will not make it a linked copy. And to do that, we're going to work it pretty much almost the same way. So if we want to have a copy of this partition, I'm going to select copy. And then coming up to the top, I'm going to right click, and this time I'm going to select paste new. So pasting new gives us the exact, or what appears to be the exact duplicate. But now, if we make a modification to this part component or this one, it is not going to be applied to that third component. In this case, I want all three of these to be identical. So I am going to right click and delete that whole part. No, I don't want to delete the face. I want to delete the entire part. And I also mentioned, you see what happened to the name of that new partition over here. So we have partition :1, partition :6. Those are those two. This is the unlinked copy. So notice that it is now kind of, the numbering system started over. It gave us a parenthesis on the actual name with a :1, meaning that it is the first of its clones. And if there is any other partition 1s, :2, :3, and so forth. Yeah, and also, well, right click, you might like, well, I want to disconnect it and rename this part. Well, see, that colon goes away. We're not able to change what comes after that colon. So we do not want that component. We're going to delete that. And just, we want another duplicate copy of the existing component, selecting copy, coming up to the top, and paste. And it's pasting it directly on top of it. So I'm just going to move that off to the side and select OK. And that way, kind of see where it's going so we could grab the edges and making sure that we grab the correct edges. Using the joint function again. And again, first time I grabbed it off the bottom, last time I grabbed it here, but it is a universal part. So it really doesn't matter where we grab that from, as long as we are connecting it with the adjacent points. Well, here, let me back up one more to show what I mean, and so everybody could see this. So again, I'm going to go the joint. So we have been selecting this point here. Now I can, again, holding the control down allows us to select here. So I'm going to select a point off in the corner. So what that now means is I have to select the mating point of this part here. So it was, on this side, but we're flipping over, so it's really going to be off to the other side. Right there. So we can see how those corners are lining up. The orientation of it is not right. It is 0, but we're going to rotate that around 180 degrees and then enter. So we now have 3 partitions that are being set there. Our next step that I want to create is the top. And this is a challenge that we get into a lot when making assemblies and parts and such. Having specific names is somewhat of a challenge in naming objects. I started off, this was called a bottom. Well, it's going to turn out that the bottom is really the same as the top. So should we have called this the bottom, or should we have called this the top, or should it be called top/bottom? That's probably the correct name for it. But anyway, we are going to make a mirrored copy of the bottom to be able to use as the top. So under Create, we have an option for mirror. And the mirror type, what do we want to mirror? We want to mirror the component. Now, if we did the bodies, well, we'll come back to it. I'm going to do the component. The component is what we're seeing here. Inside of the component, we have the bodies and the sketches. So we are mirroring the component because we want this to be a clone of itself. So when we change the data locations here, the opposite one changes as well. Then it's asking for a plane to mirror on. So if we rotate this around, the plane could be the XY plane, which I don't have those visible, or it could just simply be the face of an existing. So I selected the component, and now I want to select the plane. And here are the planes that we could mirror it about. So if I select here, it makes it a mirrored version, mirrored from the orientation of the face of that plane. You could also select an edge of that object. So I could have also selected to mirror it off of the edge of this part here, which it just would not leave that gap there. I don't like that idea just because keeping them separate, and it would really make them appear that they are together and identical. So now we want to be able to move or make this part the top and align it to the top side of our partitions. And again, just using the joint assembly function. So what I'm getting right now is, do I want to capture what I was moving around? So, we're moving the height of this part around. And when you move it around, it's asking, do we want to keep that position or revert it back to where it was? I just clicked revert back to where it was to keep it on its flat plane there. Not that it really matters. So again, I'm going to go ahead and hit the joint function. I want it on this face. So with that face kind of highlighted, holding the control key down, that means that it's not going to allow another face to be selected. Selecting the midpoint. And then if we come over to what is now the top, and selecting the corresponding or adjacent component to that. Say OK. So now we see that we have a top and a bottom. Everything is starting to come together and look like what we want it to be. And again, all of the sizing and everything for this is all controlled by the user parameters. So it's really, I think, like magic. I get excited when every time you make an assembly and being able to just change, one number and have everything scale and change with it. It's amazing what it's capable of doing. So we're going to go, everything could be changed and resized. So I'm sorry, I was pausing to read a comment and a question. It's asking if I flip the linked copy vertically, then move the dowel holes up. Well, yeah, so they're all linked from midpoint. So regardless of which way I've copied or moved or flipped around, we're constrained to the midpoint. I think that might be your question. If I didn't get it right, I apologize. But yeah, we've constrained it to the midpoint of those lines. So regardless of which way we flip these around, they are going to work. I did that not so much that making it universal that way, not so much for the purposes of creating the assembly in the drawing. I did that to make it easier to assemble when all the parts are cut out, so we don't have to pay attention, like, okay, and measure which is the top of this, which is the bottom of this. Because if we didn't, for me, if I didn't have those perfectly aligned centered being down an inch, when I go to glue this and put this all together, I will very most likely put one of these parts in upside down. But by having those constrained to the midpoint, it doesn't matter. All right, so now there's another couple more components that we need to make for this. It is the back, or I'm going to call it the back because it's the back of these components, but the front of the opposite one. So we're just going to create a new component, and I'm going to call that component back. So let's, on the table, right click, new component, and I'm going to give this component a name of back. So I'm going to right click and just kind of rename that. I don't know how that got stuck in there, but it is the back. So to create drawings and sketches and to create a model, going back to what we talked about last week, is all models are started with a sketch. And each one of these objects that we have in here are completely separate. So we could, turn them all off and not see anything except for the back. Just turn those back on. The first thing that we need to do to be able to create a model or a new part, well, the first thing is what we just did, create a component. Creating components is like #1 step in creating any Fusion product, in keeping things straight, organized, and separate at the same time. So that's what a component is. Think of a component as an individual part. So we've created the component for the back. Now with that done, we want to create a sketch. So I'm going to click this sketch button here, and it wants to know what face do we want to sketch this on. It really doesn't matter because we're going to move this around, but all my sketching is usually done on the XY plane, kind of the top view down, and going to use the triangle or the rectangle tool and just sketching out a rectangle. Need to constrain this or give this a size, and we use the dimensioning tools for that.
Hey, Ryan, can I sneak in a question?
Yeah.
You just made a comment about it didn't matter, but most of your sketching is on the XY plane.
Yes.
Does that matter later in the future when we make a file for the ShopBot, because we kind of use the XY plane as our work table? Is there any relationship there?
Yes, it sort of makes it easier later because then you don't have to rotate and move the parts around when we go to lay them out onto the material. So it does make it a little bit easier on the end process. Excellent question.
Okay, that makes sense. So yeah, thanks.
Huh?
I said that makes sense. So yeah, thanks.
Great. All right, so we could use the measuring tool here to measure what size this was, but remember we have those, what do they call them? Configured change parameters here, or user parameters. So we've gonna stretch this out. When I click, I'm just gonna type in, what did we have here? We had a length. It's not it was the width that we used. So I put an X, so I did call it width. So a lot of times it's like confusing part names in variables, very important to try to keep straight. I almost messed up there because if I would have just labeled this as width and length, I understood what that meant at the time when I created it, which was a couple days ago when I had to recreate these. But now coming into it, I'm like, oh boy, which is width, which is length? Well, I put the X on there to kind of help me understand that the X is the red line. So this line is along the X. So that's what I want for the X. So this one must be the length and in the Y. So I could have just labeled it Y, XY, but I didn't. So with those now constrained, we could click finish the sketch. And we want to be able to extrude this as a model using the extrude button, selecting that face to extrude. And again, we want this thickness to be 0.75, but we want magic to happen. So we're not going to put a hard-coded number in there. We're going to use the material thickness variable that we created to where that changes all by itself. So I'm going to say enter to there, and now we have our back model that we are going to want to create an assembly for to put into that data there. And to do that, I'm going to go up to the table, main table, setting that open, selecting the joint, zooming in and selecting the point that I want to match up. And everything is looking just right. We'll say, okay. Wow, if you see a mistake I made, nobody yelled at me. So I was calling that X and Y, but it really isn't what we wanted. There is one variable, the height is what I really wanted that to be. But that's okay. We could go in and modify that. That is what is great about being able to make these assemblies, because you're able to see straight away that if we were to cut this, it's not what we want. So it is a way to really see. Oh, Tom caught me. I'm sorry. Thank you, Tom. I should have read the chat when I did it. So we're going to modify that. And I'm going to open up the sketch under the back sketch, right click and edit. And like, you know, nothing is permanent here. We could always come in and change everything around. This height or this length is not Y, it's really height that we want to have here. And if I was consistent with my variables, I would have height underscore Z just to clarify that. We'll finish the sketch, and just like magic, there it is. We're able to zoom in and see that it all fits and it's all working together. Now, it's looking like, you know, it's quite a bit of work to get to this point. A lot of back and forth. It goes a lot quicker the more you get used to it. If I wasn't, you know, talking and, you know, babbling on here, a model like this probably would take about 20 minutes to get to this stage of it. So it's not as terribly time consuming as I'm making it look. But again, the beauty of it is the parametrics of everything. So today we have this set to be 3/4 inch material. So we've ordered the material, we've come in, lumber company dropped it off, and we found out that they shipped us 5/8 material instead of 3/4. Well, that's probably all right. And they're going to give us a huge discount if we just keep it rather than having them take it back. If we had designed this in just a basic, you know, CAD program, you know, AutoCAD or VCarve Pro, well, I probably wouldn't accept the plywood, send it back, because there's a lot of time in changing everything over to the new material thickness as far as the dados and everything else. Well, we've set this up to where just a change of one number in our variables here from our material thickness, bringing that down to 0.625, is going to magically change everything to be 5/8 of an inch. Now it looks like a couple things did not change, and that is not the program's fault. I am certain it is mine. I see all of our partitions here changed, but the tops and bottom did not. Well, let's see what's going on there. I'm going to right click or open up the tree, and in the sketching, we could see, I want to get back to the extruding section of this. So to get back there, notice across the bottom of the screen, this is the timeline that we have created everything. So right now, when we select on the sketch, you see how it's bouncing over? And so I always create sketch, then extrude, sketch, then extrude. So I now know that directly after the sketch is going to come the extrude. So this is what I want to edit. And I want to change this hard-coded number here down to the material thickness. So it didn't change because, not because the program didn't know to make that change. So I'm going to change that to material thickness, then OK. So now everything just magically changed to the right thickness. All is 5/8. Or say if we really wanted to make a beefy table and we had some 1-inch material to make this out of, we could do that just by going into modify, edit parameters, changing that material thickness to 1, and we see everything just scaled up without having to do anything else. And now we'll see next week when we go to look at toolpathing, how the toolpathing also interacts and is able to change and update and stay consistent with our user variables. At least I hope so. We're tune in next week, and that's maybe a little bit of a cliffhanger to see how that's going to work out. What else do we have to talk about here? Well, I want to make this, I see a couple hip bangers here. So if this is in a room, it's going to be, my hip is going to hit every one of these corners. So I want to round those off a little bit. And somebody's, assuming that we can make those dowel hole parameters. Yeah, absolutely. If you know that those dowels could possibly change or those hole locations could possibly change, yes, make that a variable as well. So I'm going to add a fillet here on that face, and let's go with a 6-inch. I'm just curious if it allows me to do multiples at the same time. It does, holding the control key down. And we'll say OK to that. So there is a way to do that. Other parameters that we might set is the width of each little bin here. You might want to have different width bins to quickly be able to modify and change the spacing between these bins if we wanted to. So let's just quickly go ahead and make a couple more here. I'll call that bin 1, 10 inches. And we'll say 20. So I'll just stick with 1 and 2, going in and modifying the sketch for that bottom. And again, we want to, what one do we want to do? When you select the sketch, it kind of highlights on the right here what is happening. Right click, edit sketch. And double clicking and changing these to be, there's bin 1. And we'll call for these two sides to be bin 1 and bin 2. So now that gives us a quick way to modify the width of, or the spacing that we have here. So if we need a little bit more room on the end, Bump that up to 15 inches, and we see everything shifts off to the right by the correct spacing. All right, so that is, I didn't quite get it 100% complete. I'll work on the backside this week, and I'll have it more complete next week. Maybe save a couple parts to show as a refresher on how we combined and joined them before we jump into the toolpath side of things and see how that works out. So that is kind of the end of the time that you have to listen to me. But if you want to continue to listen, ask me a question and I will continue to talk.
Hi, this is Kurt.
All right. Go ahead, Kurt. Thanks.
I have a question about the actual, like I only have a 2-button mouse and I have to click like the little pan tool at the bottom to get it to pan.
Uh-huh.
Could you talk about the mouse and the like maybe the zoom in and zoom out? I understand that's using a scroll wheel, but clicking that pan, it seems kind of cumbersome to me, but
Yeah.
so I need a 3-button mouse. Could you talk about that just a little bit?
Well, yeah. So you do have a wheel in your mouse, it sounds like, right?
Yes, I do.
Yeah. So I did not know this at first when I first started into CAD and CAM. That wheel actually is a button as well. So if you push down on that wheel rather than scroll it, you should hear a click. That click is a button. So hopefully that works for you.
Fantastic. I've been fighting that all day. Thank you very much.
So anytime I see, yeah, so that, and there's also the mouse that have the like the scroll or the wheel, and they don't have, a lot of those don't have a third button or even a scroll wheel. I can't stand those.
Okay.
And if you really get into modeling and doing this, there are other mice. I don't know if that's plural computer, but mouses. I don't know what the correct word is, but they call it a 3D mouse that is more configured to allow for 3D modeling in this way.
Fantastic. Perfect. Thank you very much.
And Donald, I think you had a question?
Yeah, it's not related to this design, but to training in the Fusion 360. This is really great stuff, and thanks for showing us this. But I noticed like have you come across any great site for training? Because Autodesk has some, as part of the subscription. I've seen a bunch of things on YouTube, some associated with Autodesk, some independent. I'm just wondering, as you were learning, did you come across one of those sites that was really excellent, or have any advice about that?
Well, I really liked the Fusion training series that they had. I was lucky in learning this because I had already known Inventor and SolidWorks and other programs like. But the site that they have on or the training videos that Fusion has on their site are very well done, organized. They are somewhat lengthy, but they are very good for, beginning learning and getting started. Now, after I got started with it, and I even used it just today because I couldn't remember how to mirror that part. So once I kind of basically understood all of the concepts, I just need to learn how to do a mirror. Like anything else that we need to learn, I headed out for YouTube and just did a little quick search and almost clicked the first one that pops up. And if they're not telling me how to do it within the first 10 seconds, I'm watching the next video to see how it's done. So it depends on what level you're wanting to learn. If you're wanting to start from the scratch and like don't know anything or any terms or any of that, there is I think they call it like working at your own pace or something like that. And it's just a nice series of videos.
Okay, yeah, thanks for the tip.
Uh-huh.
Yeah, sure, I'll ask one more. I know you, do the cabinet design, you have background in that. So, with something like the Fusion 360 and like being able to change the material thickness and have that propagate through all these parts. Because every sheet of plywood is
Right.
nothing's 3/4 of an inch, right? It's 0.68, 0.713. Do you find this like a really useful tool? So you just doing those designs in 360 now just to take advantage of things like that?
No, I would still use dedicated cabinet making software. So if you needed, a kitchen layout or, a bathroom layout or just, some sort of layout, the, programs like, KCD, where they give you the full screen to machine type action to where it's already done for you. You don't have to draw anything. It's just already done. And it works out very well that way. Or if you don't want to draw them, you've mentioned, I have the background and it's Cabinet Parts Pro, that if you don't need to have the design appearance or if you don't want to see the model of it, that works just as well too, to where you just type in the sizes. But it's all parametric just the same. It's the parametrics that make all of this easy. So all cabinet making programs are also parametric, but they even take it like one step farther in that everything is already done.
Right, yeah, purpose built for cabinet making.
Right, yeah.
Yeah, that makes sense, sure.
Hey, I have a question. I don't
Yeah.
know if I turned, okay, I did turn my thing off. I'm curious if you were going to make like a less traditional shaped piece of cabinetry or what we're making, is there a way to adjust the rectangle itself, or do you have to draw your original like bottom and top using a spline? Does that make sense at all, what I'm trying
Yeah.
to?
Yeah.
Okay.
They are all drawn, they're all made up of, lines and curves. So this is all fairly straightforward, but, within the sketches that we were creating, you are able to have, all the different shapes that you would want. If you're able to define and set the variation of them, you could extrude this or cut this out just the same with any other software. It's just, if you could draw it, it will, you could design it and cut it. Is that your question, I hope?
It does. And then I guess the second part of that question is, if I started with a rectangle, is there like a node editor like you might find in some other software?
Well, let's explore. I don't think it's quite the same way. Yeah, I don't know the question to that one. I apologize. I will research that and see what I could come up with for next week. I'll answer that question. I know it's not quite the same because it is different. But I will look for the alternative way to handle node editing.
Thanks.
Mm-hmm. All right. Well, thank you all for joining us today. We'll be here again next Thursday at 2 o'clock, expanding a little bit more, drawing a couple more components, and then getting into the tool pathing. And we'll figure out how to get all this laid out onto our material. Everybody have a great week, good weekend, and we'll see you next week.